All right, so this unit is going to have three chapters. We're going to have the respiratory system and then digestive system. And then we're also going to be talking about the nutrition and metabolism, although that third chapter will be a bit shorter. As you will see, there will be some things that we will actually not be covering because they're kind of a review from AMP1. So the nutrition and metabolism, the lesson is already actually posted for you on your Blackboard. So you can watch the video about that already if you would like to get ahead. All right, so let's talk about the respiratory system today. The respiratory system is part of our body that's responsible for breathing. At least that's what you usually think of when you hear the respiratory system. However, the term breathing is pretty general term. So we're going to look at the general functions broken down a little more specifically. The structures of the respiratory system provide passage of air with the ultimate destination being the alveoli. Alveoli are tiny little air pockets that are found in your lungs, and these are the primary sites of gas exchange. And this is where the gas exchange, when you hear the term gas exchange, this means that carbon dioxide moves out of the blood into the alveoli so that you can ultimately exhale this, and oxygen will move from the alveoli into the blood. So carbon dioxide and oxygen are always going to be moving in opposite directions. As air passes through the structures of the respiratory system, two other things are going to happen, which are not associated really exactly with gas exchange. And this is going to be detection of odors and in the olfactory region of your nasal cavity, and also production of sound as the air passes through the larynx and vibrates the vocal cords. We're going to switch to this next slide now. The respiratory system is structurally divided, as you can see on the slide. If you are in the Nearpod, well, actually, you can see it on your screen too. The respiratory system is structurally divided into upper and lower respiratory tract. Upper respiratory tract is going to include the structures that are found in your head. So this is going to be your nose, nasal cavity, and pharynx. The remainder of the respiratory tract is classified as the lower respiratory tract. You can remember this by remembering larynx and lower. So both are going to begin with the letter L. So larynx is where your lower respiratory tract begins. The respiratory system can also be divided based on function into conducting zone and respiratory zone. This is the division based on what is happening in this part of the respiratory system. The conducting zone is responsible for conducting or moving the air towards the respiratory zone. And then the respiratory zone is part of the respiratory system where the gas exchange is actually taking place. So you need to be familiar with these structures that you see on the slide. So make sure that you are able to classify things into upper and lower, and then conducting versus respiratory zone. As you can see for the conducting and respiratory zone, the division here, there are only three things that you can find in the respiratory zone here. And that's your respiratory bronchiole. That's the first part, the first bronchiole of the respiratory zone. Then your alveolar duct, and then alveoli. You might also hear the term alveolar sacs, and these are the groups of alveoli. So it's kind of like when you think about a bunch of grapes, right? Each individual grape would be an alveolus, that's a singular, and then a bunch of those grapes on that stem, I guess, would be the alveolar sac. Okay, all of the grapes together in that area. So let's go to the third slide here. And here, we're gonna play a little game here. Okay, waiting for players. And I think I only have like 3 people here. I'm running this from my computer today. I'm still trying to kind of figure out what's better for for me as far as, managing all these devices. So I'm working without the iPad today. All right, let's go ahead and get started. And this was really loud for me. Okay, so this would have gone with, like, this goes with the previous slide there. I can hide the names. All right, good job, guys. The bear won today for this one, this activity. So let's go ahead and keep going. The respiratory system, as is shown on this table, the respiratory system is lined by a progressively thinner and thinner epithelium. And as we move from the upper respiratory system towards the alveoli, you will see that the cells are going to get smaller and smaller as far as their thickness goes, okay? The upper respiratory system is almost exclusively lined by pseudostratified glandular ciliated columnar epithelium. That is a mouthful, okay, but it's pseudostratified. That's just the type of epithelium. Glandular because it contains glands that are producing mucin. It's ciliated, so you do have to, whenever you're naming tissues, you know that you have to say if it's ciliated. And then it's columnar epithelium. And I said almost exclusively because part of the pharynx is actually shared with the digestive system. And for this reason, it must possess epithelium that is able to withstand abrasions from passing food, so that the pseudostratified columnar epithelium would not cut it in these areas. It would get damaged too easily. So this epithelium that you see in the areas of the respiratory system that are shared with the digestive system is the non-keratinized stratified squamous epithelium. And you would find this in your oropharynx and laryngopharynx. You also find this epithelium in the upper portion of the larynx and vocal cords. Note that the larynx, even though it contains this type of epithelium, it is not shared with the digestive system, okay? It's just this type of tissue that extends into that part of the purely respiratory system there. So I need you to know that, this epithelium gets progressively thinner and thinner. You do need to know where we can find these exceptions. So make sure that you maybe create a table or something that will help you organize this material, okay? So let's go on to the next slide. And here we're going to actually match the type of epithelium in different parts, I think. Yeah. Oh, wait, I didn't. Oh, okay. Yes, and it's actually in the upper left corner. Okay. Okay. "45 more seconds." And it doesn't let you make a wrong match. If it's a wrong match, then you can just keep trying. But it's a way that you're connecting, those the different types of tissues with different structures. So in the one that's self-paced that I uploaded, it is actually narrated, and I'm going to be pretty close to what I'm saying here. And you can redo these activities again if you would like. Okay, everybody's done. So we're gonna move on. And we're gonna start talking about the upper respiratory tract and the nasal cavity. So the nose, nasal cavity, and your pharynx are what's making up the upper respiratory tract. Nose is the first part of the respiratory system receiving air. So you should inhale through your nose if possible. It is made out of cartilage, bone, irregular connective tissue, and skin that covers the whole structure of the nose. When you suffer a broken nose, actually, the fracture occurs in your nasal bones. So you can use your fingers and you can feel where your nasal bones end and then the cartilage begins, right? So a fractured nose generally involves the bones, the actual nasal bones. You can also dislocate these bones without breaking your nose. And you can see that most often, I guess, probably with boxers, okay, or fighters. Somebody punches them in the face and they hit them in those bones. Those bones can shift, and that's when the nose looks like it's all crooked. And you can just put them back in there. So, but anyway, so you can dislocate those bones, just FYI. So we're gonna look at the cartilages, that the softer part of your nose here. The larger side cartilages under the nasal bones are known as your lateral cartilages, so lateral on the sides. The cartilage running in the middle, that's your septal cartilage, and this is going to separate the nose internally into left and right sides. The nostril is formed by the alar cartilages and dense irregular connective tissue, and then all of this is covered by skin. So again, make sure that you're able to label all these things. Here we're going to look at deeper features, more internal features of the nasal cavity. The nasal cavity is separated into 3 distinct regions that are color-coded for you. We see the nasal vestibule. This is right past the nostril. Nostril is the opening. Then there is the respiratory region. That's the largest part and the largest surface area. And then there's the olfactory region responsible for your sense of smell. And you can see that highlighted in the orange there. The nasal vestibule contains vibrissae. I think that's how you say it. And they're not labeled here, but this is basically your fancy word for your nose hair. These are going to trap your large particles, which are part of air and which need to be kept out of your respiratory system. And if you actually remember chapter 22, that big page that integrated everything together, and you saw that baby with the little block on that picture, it was actually talking about that being part of your preventing entry feature, right? Olfactory region contains receptors. These receptors are going to react to chemicals in the air, and then we translate that into different odors. And then respiratory region is responsible for warming up the air to about 36.5 degrees Celsius. This is close to your body temperature, normal body temperature. And as it's doing this, it's also humidifying the air, as the air is passing through your respiratory system. The air is being humidified to about 85% humidity before we send it to the rest of the respiratory tract. And there's also further purification of the air by means of mucus. So as the air is passing through these passages, things that are maybe smaller that got past the nose hairs will get trapped in the mucus. Mucus also contains some antibodies, and these antibodies like to, or not like to, but they are able to neutralize various pathogens. Conchi are the bony structures dividing the respiratory region into nasal meatuses, and these compartments allow for creation of turbulence inside of the nasal cavity. Okay, conchi you should already be familiar with that from AMP1 when you were doing skeletal system. So those were parts of the bones that you had to identify, right? So hopefully you remember that, and it's not completely new. This turbulence, so as you have these compartments, and you can see on the coronal section, on the cadaver on that picture, you can see really well how the conchi are formed. Notice that they're kind of like, it's almost like a twisted bone, if that makes sense. So if this was the bone, it's kind of like this, you know, twisted, kind of like that. I don't know if you can see me, but okay. And so that creates kind of more surface area in there, which allows for better humidification and warming up of the air, as well as purification. Okay. So that's that. Make sure you're able to tell me that meatuses are the spaces, conchi are the bony parts, and be able to label these things on this image right here. All right, let's see what we remember. Okay, let's do space today. I mean, not today, this time. All right, we've got 3. Let's go on. I left too much time for this one, for each question. It's going kind of slowly. All right, good job. I think that's a fox. Good job, fox. And let's go on to the next part. So now we're going to be talking about pharynx. Pharynx is kind of boring, really. There's not much that we're going to say about pharynx, but pharynx is also known as your throat. It consists of 3 parts: nasopharynx, oropharynx, and laryngopharynx. While nasopharynx is strictly part of the respiratory system, the other two parts are shared with the digestive system. And remember, because of this, the epithelium in the oropharynx and laryngopharynx is non-keratinized stratified squamous epithelium, and this is able to withstand the abrasions from food passing through this area. So that's that about pharynx. Okay, larynx, however, we're going to talk way more about compared to the pharynx. So larynx, remember, larynx is going to begin our lower respiratory system. It's also known as the voice box. Its functions, however, are not only for sound production, but it also helps with increasing abdominal pressure during Valsalva maneuver. Valsalva maneuver is where you are able to hold the air here in your lungs, basically, and then you can push your abdominal muscles. It's used during childbirth, but it's also used in defecation and urination. So that's Valsalva maneuver, where you're holding the air and just pushing down there. Okay. The larynx keeps ingested materials out of the air passage with a structure that we know as epiglottis. And it also helps remove irritants out of the respiratory tract in cough and sneeze reflex. So larynx participates in cough and sneeze reflex, and that gets things out of our respiratory tract. The largest cartilage of the larynx, as you can see from this image, is the thyroid cartilage. Laryngeal prominence, or Adam's apple, is an anterior projection of that thyroid cartilage. It's the upper anterior projection, and you can actually touch it and feel it, and you will kind of see how it goes like that, okay? The angle of this cartilage is smaller in males than in females, and this allows for longer vocal cords in males. They have that sharper projection in males. And because of that angle being different, the vocal cords can be longer in males. The vocal cords are actually attached, or vocal ligaments really are attached to the inside of the thyroid cartilage there. Yes, because the longer vocal cords are going to mean a lower range. And I actually have a little video on the sound and how the sound is determined. So which I don't know where I put it. I think no, I'm gonna actually talk about sound today, because I know for one of my sections I've created a separate little section on the sound. But yeah, no, I'm gonna talk about it today. So yes, that's the reason for deeper voice, because the range is lower the longer the chords are and the thicker they are. So let's go on. Okay, so the vocal cords are attached to the inside of the thyroid cartilage on the anterior side of the larynx, and then on the back of the larynx, they're attached to the arytenoid cartilage on the posterior region of the larynx, and you can see that in that middle view here. So if you're looking at the middle view, you can see where the arytenoid cartilage is, and the ligaments would be the vocal ligaments would be attached to those arytenoid cartilages there. So that's hold on. Is this my slide? No, I want to stay on larynx still. Okay. No, I'm going to stay here. Let's talk a little bit about hold on, because I have an activity here, but I wanted to talk about this other slide, right here. So did I want to have this here? Let's see. One thing that I don't actually see when I run this from my computer is I don't see what the matches are. Like, what are you matching? It just shows me your results. But I guess it wasn't that hard. right? All right, good. Everybody matched whatever you were matching. I forgot what you were matching. All right, let's talk about the intrinsic ligaments. They are basically the internal ligaments. Okay, so the ligaments seen in the larynx can be extrinsic on the exterior of the larynx, or intrinsic, they're on the interior of the larynx. That's what those words mean. There are two important intrinsic ligaments in the larynx: inferior vocal ligaments and superior vestibular ligaments. Both of these are covered by mucosa, and both are actually avascular. These ligaments whenever they're covered by the mucosa, are called folds. So sometimes we just use the ligaments, folds, cords kind of interchangeably. Technically, the ligament is the internal ligament. And then when the mucosa covers it, it's fold, but you might see them just kind of be used interchangeably. The vocal folds are also known as your true vocal cords because they participate in the sound production. And the vestibular folds are known as the false vocal cords because they do not participate in sound production. Vestibular folds provide protection for the true vocal folds, but again, they don't function in sound production. And they're above the true vocal cords. It is not obvious from this image, yeah, but the rima glottis, rima glottitis, or opening between the vocal cords, is narrower than the rima vestibuli, which is opening of the vestibular folds. So the rima is opening of, okay? So basically what that means is your vocal cords are closer together. The opening between them is narrower. The false vocal cords, or the vestibular folds, are farther apart, and they're actually superior to the true vocal cords, okay? They used to have a picture for this with both of them in the image, and then they got rid of it, so now you only see the true ones on here. You can also see from this how the arytenoid cartilage can change position. So those muscles that we saw, I haven't named them, but you should take a note of what these muscles are. They're that you saw on the whole picture of the larynx. They are able to rotate these cartilages and change their position. As these arytenoid cartilages change position, they change the opening between the two ligaments, and they also are going to change the tension there a little bit. So while we're talking about larynx, now let's go ahead and talk about sound. That we have this up here, this picture here, and how characteristics of the vocal cords are and different conditions affect the sound that we produce. So starting with loudness, because I think that's probably the easiest one. Loudness depends on the force of air passing through the larynx. So the stronger you push the air through, the louder the sound you're making. So you can try yelling, but holding air behind. You can't yell and not use a lot of air, right? Or you can't, and vice versa. You can't really whisper when a lot of air is being pushed through your larynx. Okay, so loudness depends on the force of the air that is going through your larynx. Range is going to be the collection of pitches you're able to produce. Everyone has a limit of for the highest and lowest pitch that they can produce. So you can try this. I can't hear you, so you can try it even now and try to make the lowest sound you can. There will be one tone below which you simply cannot go. And it's the same with the upper limit, with the highest pitch that you can produce. Yeah, her range is crazy. Mariah Carey's range is just wow. So anyway, this limit depends on the length and thickness of our vocal cords. The longer and thicker the cords are, the lower the range is. Okay. And you can, if you've ever seen like a guitar or like a string instrument, I do have a guitar behind me, but anyway, if you have seen a string instrument like a violin or a guitar, you will notice that the strings are different thickness. The thickest string has the lowest range. Okay, this is the one that produces the lowest tones. And then the thinnest string is going to have the highest range. Okay. So that's range, and then the pitch is the individual tone. Okay, it's the individual note that you are producing. Okay, so a pitch is the frequency of the sound, and this one is going to depend on the tension of the vocal cord. So the higher the tension is, the higher the pitch is. And again, if you have ever seen a string instrument such as a guitar or a violin, you know that you tuned the instrument by changing the tension on those strings. The higher the tension on that string, the higher the pitch goes, right? So so that's our sound. All right, well, let's talk about our trachea. Oh, wait, first match some things. And let me actually grab this. All right, almost done here for this. Okay, good. So everybody's done with that. I just wanted to show you, here's the guitar. Okay, you might not, hold on, actually let me stop share here. I'm not going to sing. Okay. But here's a guitar. Okay, you can see the strings have different thickness, right? So this is your lowest one and this is your highest one. Okay, so the thickness of the string determines its range. And it's kind of the same with our vocal cords. I'm not going to change the tension because this is actually tuned right now. My daughter wouldn't be all that happy if I messed it up for her. Okay, so that's all the music that you're gonna get from me for this one. All right, let's go back to our Nearpod and work our way to wrapping up here. All right, so let's talk about trachea. Our trachea is our windpipe. And it consists of tracheal cartilages. These cartilages are connected by annular ligaments. And from the anterior side, from the front, you might think that the tracheal cartilages go all the way around, that they're circles, but they actually are not. They have a letter C shape. The ends of the C are connected by a trachealis muscle on the posterior side. And trachea ultimately splits into left and right main or primary bronchi. There's going to be one for each lung. This split creates an internal projection into the trachea, which is known as the carina. And there are receptors in the carina which can detect irritants, and these receptors can initiate the cough reflex. The expulsion of air during the coughing is aided by the trachealis muscle, since they can alter the diameter of the trachea. They can contract, making the trachea narrower, and that helps with the forcing the air out of the trachea. So that's our trachea. So continuing down, lower and lower, we generally use the term bronchial tree to describe the branching of all the bronchi in our body. Trachea branches into two main or primary bronchi, one for each lung. And each of the primary bronchi are going to enter lung at its hilum. The lungs have a hilum from their medial side. Each main bronchus is then going to branch into secondary or lobar bronchi. And there's going to be one secondary or lobar bronchi per lobe of each lung. The right lung has 3 lobes, so there are 3 lobar bronchi, and the left lung only has 2 lobes, so there are 2 lobar bronchi on the left side. Each lobar bronchus further divides into segmental or tertiary bronchi, and there is 1 segmental or tertiary bronchus for each segment of the lungs. And you don't have to memorize those segments. There's a picture that names all those segments, but I'm not going to ask you to label those. It's a very colorful picture of lungs, so you will know when you come across it. So you don't need to memorize the segments, but you do need to know the lobes. These segmental bronchi then divide into smaller and smaller bronchi, then eventually bronchioles, and then alveolar ducts, which ultimately bring air into the alveoli in the lungs. So right here, you can see branching of the bronchi in a bit more detail. This figure also shows you that bronchioles are capable of dilation and constriction. However, mine got cut off here. So if you have your textbook somewhere nearby and you are seeing this image, it shows you a constricted bronchiole and dilated bronchiole. So it's just changing of the diameter of the bronchioles that is vasoconstriction versus vasodilation. So oops, okay. Let's see what you think here. So looking at here, you can see the whole thing, okay? So other than the size, what do you think is the difference between bronchi and bronchioles? So look at that picture, observe it for a while, and see if you can see what, like when we start talking about bronchioles, what is one structural thing that is going on with these? Okay, we have 1 vote for type of tissue, 1 answer that says air pressure. Any other guesses? Muscle appearance. It's kind of almost going with that first one there. And so let's look at that again here, right? So if you see muscle, what do you not see in bronchioles? And on your end, you can also click on this and enlarge this, right? Amount of cartilage, that's what I was going for. Which type of the first and the last one kind of had to do with the air pressure. There would probably be a difference in air pressure in them as well. You can't tell that's what's going on from the image though. But okay, so let's blow it up again. Notice that bronchi, when we're talking about bronchi, there is cartilage. So there's the big bracket on the right side, yeah? And that's the cartilage. So this one has cartilage. Once we stop seeing the cartilage, then we're calling these things bronchioles. Hold on, my chat went away. And yeah, and then lumen size would be a thing as well, right? I mean, because they're branching, so they're going to be smaller and smaller branches ultimately. Okay, but it's the cartilage appearance or disappearance rather, that determines that you're talking about bronchioles now. All right, let's look at the alveolar sac. Alveolar sac is composed of several alveoli grouped together, as I've mentioned earlier. These are going to receive air from the alveolar ducts, which are branches of the respiratory bronchiole. Respiratory bronchiole is the first structure of the respiratory zone, and respiratory bronchiole is a branch of a terminal bronchiole. Terminal bronchiole is the last part of the conducting zone. Respiratory bronchiole is the first part of the respiratory zone. Okay, it says respiratory bronchiole, so do not put respiratory bronchiole into conducting zone. Okay, if it says respiratory, it's part of respiratory zone. For these, it's almost better to go kind of backwards. When you're looking at the alveolar sac, find your alveolar duct, then you know that the branch before that was your respiratory bronchiole, and the branch before that was the terminal bronchiole. Respiratory bronchioles have alveoli on them, and therefore can serve as gas exchange, sites of gas exchange here. The deoxygenated blood is brought into this area, into the area where the alveoli are, by a branch of your pulmonary artery. This will eventually branch into capillary beds surrounding each alveolus. So each alveolus is surrounded by these capillary beds, and gas exchange will occur where blood capillary and the wall of the alveolus meet. And at this place where the capillary touches the alveolus, their basement membranes are going to fuse. Okay, so at this place, the basement membrane of the capillary and the basement membrane of the alveolar epithelium are fused together. And alveoli are surrounded by many elastic fibers, which have a natural tendency to recoil. When you breathe, you actively stretch these fibers, and during a quiet expiration, that's what you do. You stretch these fibers, you stretch the lungs, and then when you exhale, you just relax the muscles that are helping with increasing your thoracic cavity, and the lungs return to their normal state thanks to these fibers. Yes. So the question was, is that connective tissue at the bottom? Yeah, I don't know if it's actually labeled as that, but yes, everything is kind of supported with connective tissue around it. Okay, so make sure that you know what a lung looks like. It looks like a lot of empty space. You don't need to be able to label anything within the lung, but know what a slide of lungs would look like. Notice that you have a very thin lines of cells there. These are squamous cells here, and they are very thin. So it's like looking at a very thin slice of a sponge. You're not going to see much stuff. You're going to see a lot of space, right? And then the bottom picture shows you the electron microscope picture. So you really see that it's very spongy. Okay, and all those little holes, those are the alveoli. Okay, so when you look at the structure of the alveoli a little closer, you can see several different types of cells. Cells that are going to make up your alveolus, the walls of the alveolus, are known as alveolar type 1 cells. There are also alveolar type 2 cells. These alveolar type 2 cells are cuboidal cells. They don't quite look like that on the picture, but they're actually considered cuboidal cells, and these produce surfactants. You need surfactants to reduce surface tension between water molecules that line the inside of the alveolus, because the surface tension is favorable to alveolar collapse. Okay, the surface tension is like attraction between water molecules, and so you have to kind of work against it so that your alveoli do not collapse and stick together. So there is a video on the next slide that will talk about this concept. And I guess we can, or maybe I should have, I don't know, hold on. Let's do it like, I don't know if it's better for me to play it from mine or from yours, or if it's going to play double. So I'm going to actually let you watch this on your own. This is the last part that I have for today. And the next will be this, and I have that posted in the form of the Nearpod. It is narrated Nearpod. It's me narrating it, and so hopefully you will look at that. It's in 2 different sections because it was too big to make it all one single file. Okay, so I have posted actually already the first part of the Nearpod. It is also narrated. I will go ahead and post this video as well, so you can go over that, and then I'll post the second Nearpod for you soon. So that's it. I'm gonna stop here for now. And yes.